Hello all, good evening all of you. My name is Shashank. I have more than 10 years of experience as SAP technical consultant. I have worked worked on various modules like SAP Workflow, WebDen Pro, um, SAP OData, uh, enhancements, customer exits, implicit enhancements, baddies, PAPI, and I feel all one concept is common in all the uh, among all the module, which is object oriented concepts. So that's why I'm going to start tutorial on object oriented ABAP programming, and here I'm going to explain all the concepts and its uses in SAP programming. So let's first understand the benefit of using object oriented programming. So first is reusability. Code can be reused at multiple places, and just you need to move to the global method of global class, which is SE24. It's a class builder in SAP ABAP. And second thing is code is properly maintainable. So as you see that code is organized in methods, so it is maintainable. So maintainability is increased in object oriented programming. And third thing is you can achieve you can restrict the uses of particular method that you can't do in procedural programming. And code modularization can be achieved using object at higher degree using object oriented programming. Um, so so these are the advantages that is why this approach is very well adapted um, used by SAP. So let's understand some principle in object oriented. uh, so first is inheritance, second is polymorphism, third is encapsulation, and the last one is abstraction. So first, let's understand um, the class and object. So so uh, here the the code is developed in such a way that we picturize everything as an object. Okay, so we code in that way. So for each and every uh, for each we treat that functionality as an object, and then we create class. Okay, and and class contains attributes and behavior. And so it basically attribute means variable or uh, variables in the class, and behaviors means method. Okay, and so as you can see in the figure, uh, eh, so behave means a class can have multiple behaviors and attribute, and it works on certain category of data. So this is the basic this that's how objects should look like actually, and that's how we should write the code actually in this programming. So let's understand the meaning of inheritance, polymorphism, and abstraction and encapsulation. So inheritance is means it is simple. So if you are inheriting something, some property or something from someone, then it is inheritance. So whether so best example is parent child relationship. So child definitely inherit some attribute from their parent. So that we use that this concept we use in object oriented way. And second is polymorphism. And so the meaning of polymorphism is if certain things is behaving differently at certain at different places, then it means this is the polymorphism. So suppose a student named Kanu acts as a student in a school, and if he goes home, he acts as a son. So the Kanu is same, means object is same, but Kanu is different, behaving differently at school and at home. And let's move ahead and understand the abstraction. So abstraction is basically means hiding the complexity from the user. Like if you consider real life examples, let's take the example of drive. So sorry, car has accelerator, clutch, and brakes. Okay, so driver just know how to use it, but there are there is mechanic of each and everything which is there, but it is not essential for the driver. So it so abstraction means hide all the things which are non-relevant for someone is uh, is the abstraction. So it's just hiding non-relevant thing from someone. Now let's come to encapsulation. So encapsulation is mean like limiting the uses of attribute or certain method. So you can like you can do that via access modifier like public, protected, and private, that uh, that I will explain you in detail in further sessions. So so just understand that limiting the restricting the use of particular method is a encapsulation. So let's move ahead and let's do some hands-on and let's understand how inheritance, polymorphism, all these concepts, how how they are working. Okay, so I have defined one superclass, and it has attributes and method as well, some public methods and some private method, and I have also defined subclass. Okay, so mm, it has its own method as well, and I have used one keyword inheriting from LCL SP class, means all the property from this class will be inherited uh, uh, in the subclass. So subclass will inherit all property of superclass, and it will have its own property as well. So this is the meaning of inheritance. So here in this case, superclass subclass is inheriting the all the property of superclass. So this is inheritance. Okay, and now let's come to polymorphism. So here in superclass M1 M2 methods are there. Okay, so now if I try to declare M1 or M2 method here, we will get error because M2 method is already present. M2 property is already present in subclass because it inherited from the superclass. So that's why this syntax error is coming. But uh, so if you want to achieve polymorphism, then what you can do, just add the this keyword redefinition, and now error will be gone. Okay, okay, let's provide the redefinition of M1. Okay, So I want M1 to behave differently in subclass as in and in superclass. So I have redefined this method. uh, okay, and if I'll check it, the syntax error is gone, and now I can activate. Okay, so in M1 I have provided different implementation from the superclass. In superclass I am printing I am superclass method, and in subclass I am printing I am subclass method. Okay, so let's uncomment this. So I have declared reference variable of superclass and subclass. I just want it. I just want to see how M1 is behaving when it is being called from superclass and when it is being called from the subclass. So let's see and execute this program. And if you see here, uh, and let me comment out something. Let me comment this M2 method. I will. Okay, so it is first M1 is printing I am superclass method, and second M1 method is printing I am subclass method, because it is behaving differently because the reference variable is different. So the situation is different, but the person is same. So when person behaves differently at different situation, it means polymorphism. Okay, so I hope you got it. You get it. Now let's come to abstraction. Um, so let me comment out this code, and let me uncomment this one, this line. And here I am just calling M2 method. Okay, and let's see the output. So it is saying I am method of class this. Okay, but now if you are looking, look at this line, it is just we are just M2 method is being called. Okay, but if you go to M2 method, the output is getting formed using M3 and M4 method as well. So basically we are hiding M3 method and M4 method. Okay, so from here you can't guess that M3 and M4 is also being called. Okay, now if you are going now if you look at the implementation of M2 method, now you'll come to know that M3 and M4 uh, M4 methods output uh, are brought together to form output of M2 method. So, this is simply hiding the complexity. Okay. So this is the abstraction, and now let's come to encapsulation. So if you see, M3 method is a private method. Okay, so all the this M1 method and M2 method we can use anywhere because these are the public method, but we can't call M3 or M4 anywhere else. Means we can use these methods only inside this class. We can't use these methods outside of the class. That's what. So here we are limiting the use of M3 and M4. So this is the encapsulation actually. So because M M3 and M4 method is just helping M2 method. It those does not those do not need to be called from the outside. So using private access modifier, we have limited the use of M3 and M4. So this is the encapsulation. So that's all for now. I will see you in another session with other concepts. Uh, Thank you for your time and see you in next session. Thank you. Bye bye.